Now, as always, I'm in a brand new empty project, an empty Go module that I created. And I want to start with the fact that functions, these things which we have written over and over again, are first class values in Go and what that means for us. Now, for that, briefly, let's recap what a function is. It's a piece of code that we can execute on demand. We give it a name, we can accept parameters, and we can return values, even multiple return values, as we learned. Now, what we did not learn up to this point, but what we can also do with functions in Go, is that we can use functions themselves as parameter values for other functions. And this might sound a bit cryptic and strange, and therefore I want to give you a concrete example. Let's say we have a couple of numbers, a slice of numbers to be precise, and I'll just quickly create it here with the composite literal notation. And I now want to double every number in that slice. Of course, for this we can write a for loop here, and we can go through all the numbers and then perform this operation with that for loop. But let's say in the program we're writing, we might have multiple slices of numbers in different parts of our program, and therefore we want to outsource this loop, this operation, into a separate function. Well, we can do this. We can add a function, double numbers, and there we take our numbers as an input, and that could then be a slice of integers. Or maybe it's also just a pointer at such a slice of integers, and we then loop through our numbers there. For example, with the range keyword, where we get the index and the value, like this. Then we can loop through our numbers, make sure to dereference the numbers, of course, and now we can either edit the numbers in that existing slice. That would easily be possible since we get a pointer to that original slice, or let's say we return a new slice here. So we got our D numbers for doubled numbers here, which is a brand new slice of numbers, which initially is empty. And now for every number through which I'm going here, I will add it to D numbers with append. So here I append to D numbers, and the value which I want to append is the value from the input numbers. So the value, the slice, which will pass to this function when we call it, times 2. And that will return a brand new slice, which I will of course store back into D numbers. I'm not going to use the index, so I'm using that underscore symbol here to signal that I don't care about that value here. And I just return my doubled numbers here in the end. That's how we could write this utility function here. And with that written, in main, if we want to double our numbers, we can add a new variable here, let's say, call double numbers, and pass numbers to it. To be precise, since I'm expecting a pointer here, I'm using the ampersand symbol here to get the address of numbers. If I would expect a slice instead, we would pass it like this, without the ampersand, but then a brand new copy is created all the time, and you'll learn about that throughout the course. So I'll accept the pointer here and pass the address, and then I get my doubled numbers, and hence last but not least, we can use the format package, import it, and call println to output the doubled numbers. Now with that, we are just repeating what we already learned, but this is an important first step to then understand what I mean with functions as parameter values for other functions. At the moment, we're not using that feature yet. But with that code here, if we now open the terminal and run this, we of course get our doubled numbers here. But now let's say our goal here is to not have this double numbers function, which only works on slices, but instead we might want a general double function that doubles integers themselves. So not slices of integers, but single integers. For this we could add a function, double, which takes a number, which is an integer, let's say, as an input, and which returns an integer, but it returns the input number times 2. Now I have this double helper function, which I might also be using in different parts of my code. And deliberately I'm keeping this function simple here. Of course, we could also have functions that do more complex things. Now with that double function defined, we could of course use this here instead of doubling this number manually here, and execute double and pass our value to it. So this value, this number which we get by going through all our numbers. Now we have another utility function. But here I'm passing the result of calling that function to append, and that's also not new. We have been using the results of calling functions as parameters for other functions before already. But now comes the interesting part. Let's say we don't just have a double function, but we also have a triple function, which triples the value, just as a dummy example. Now, if we want to have a function that goes through all the numbers in a slice and triples those numbers, we have to write a brand new triple numbers function where we repeat all that code just to then call a different function here inside of that for loop. And that's where this functions are first class values feature can now come in handy. It would be pretty nice if double numbers would be less specific. If instead of double numbers, it would maybe just be a transform numbers function. And the exact transformation is not hard-coded into the function as it currently is, but instead, besides our slice of numbers, or a pointer to that slice, we maybe also accept a second parameter value that describes the to-be-performed transformation. And that's where it's now handy that in Go, we can also pass functions as parameter values, and we can therefore accept functions as parameter values. And that's exactly what I want to do here. Because the second parameter, which I expect here in transform numbers, should be a function that is then to be executed in here. I'll name this function transform, but that's up to us because it's just a parameter value in this function, just as numbers here was up to us. But the type of this parameter value is now interesting because it will be a function type, which we define in Go by again using the func keyword, but now in a place where a type is expected. And then we just add parentheses here, but not to define parameters, because we're not defining a function here. Instead here we are defining the type of a function, and hence here we just define the types of the parameters the function should have that we get here as a transform parameter. And here we want to make it clear that we want a function that is able to handle ints as inputs, and that then returns an integer. So with that, we're defining the type of a function instead of the function itself. And we're saying the value that we receive here for this transform parameter should be a function that has one parameter that is of type int, and that then returns one value which is of type int. And the function type can of course anything you want. We could also want a function that has two parameters, an int and a string, and that maybe also returns multiple values, an int and a bool. Like this. That would all be possible. But here I just want a function that returns one value, an integer, and that takes one value, an integer. But now with that we get this transform parameter, and we know that in this transform parameter we'll have a function. So here instead of calling double, I can now call transform, because again this will be a function, hence I can execute it as a function, because we force it to be a function here. And now here where I want to double my numbers, I can now execute transform numbers and pass in that second parameter value, which, and that's important, is now a function. It's not a number, not a slice, not anything like that, but a function. And that's what I meant when I said functions are first-class values. You can pass functions around as values just as you can pass other kinds of values around. So just as we can pass a slice or an integer into this transform numbers function, we can also pass another function into this function. Might sound complex and tricky at first, but it's actually straightforward. Functions are just values in Go in the end. And therefore here, I can now use this double function here and pass double like this into transform numbers. The important thing here is that we don't execute double. If we would execute it here, we would pass the result of executing double into transform numbers. But here we want the function itself, not the result. Hence we don't have parentheses here, and we instead just use the name of the function. Again, just as we use the name of a variable in other places as well. Because again, we're just using the function like a value, because in Go it is just a value in the end. A value you can execute, but also a value you can pass around. So here I'm passing the double function into transform numbers, and this double function will then be executed inside of transform numbers here because it's received as an extra parameter. And the advantage is that we now can easily also get our tripled numbers here by calling transform numbers with the triple function that I also defined down there, pointing at that triple function by its name. And hence now here, I can of course also output tripled. And that's now the advantage of using this feature. It allows us to write more concise code. Because without that feature, we would have to copy this entire transform numbers function here just to write it once with double and another time with triple inside of it. Now that we know that we can pass functions themselves as parameter values, we can save that unnecessary code duplication, we can avoid it, and we can instead just define this generic function once, and then accept the specific transformation function that should be executed inside of it as a function parameter. That's what we're doing here. And therefore now, if I run this program, we see the doubled and tripled numbers here. So that is working. And now that we know about function types, I can also come back to a feature we learned about in the previous course section: custom types. Function types can get rather long. This one isn't, but that's just a function with one parameter value, which type is pretty short, and one return value. Imagine that you want a function here that maybe takes 3 parameter values, and one of these values is a map full of slices or anything like that. Then such a function type definition can get rather long. That's why you can also store function types as custom types. Here I can add a type transform fn maybe for transform function, and simply store this function type in it. And now I can use this custom type down there, just like this, and everything still works. If I save that and I then run this again, we still get the same output as before, but now we have less typing to do here in our code. And as mentioned, that's particularly helpful if you have more complex function types, like another function here, let's say, where you expect an integer, and then maybe a slice of strings, and then maybe a map where the keys are strings and the values are maybe slices of integers. And you want to have 2 return values where one of them is a slice of integers and the other one is a string. That's just a made up complex example, but that's a pretty long function type. And if you would have to repeat that over and over again in your code, that could be pretty annoying and error prone. Hence, saving that in a custom type where you can then just use this custom type in your code instead of this can definitely also be useful. We don't need it here, we're not using it here, but I hope it's clear why this can be helpful.